Hello, friends. Podcasting Chapter 10 in your AP Stats book. I'm using the built-in microphone on the laptop computer, so the sound may not be ideal. But I will plunge on with, we are finally to inference. And remember, I've said for quite a while now that inference is really two things. It's hypothesis tests and confidence intervals. In Chapter 10, we are going to learn about making confidence intervals. So we have some statement, and if you read in your book, it's pretty important to read, maybe reread exactly what inference is and specifically confidence intervals for this chapter. You've got questions they pose. How long will a battery last? What proportion of a college population will binge drink or do anything? So you have some statement, and then a confidence interval is simply this. You state a level of confidence. I am 95% confident, typically, that the true population parameter, either the proportion or the mean, is between two numbers. So the two numbers are the interval, but every confidence interval also comes with a level of confidence. So you've got an explanation here for what confidence intervals are and significance tests right in the introduction. All right, and as promised, we are going to be weaving together a lot of the ideas that we've already talked about all year. So in addition to studying confidence intervals, at the same time, we'll be reviewing concepts that we've talked about earlier in the year. And that's what they do with the first example. You should pause this and read the example or look at it in your book. Essentially, in the problem, the admissions director wants to know the IQ of the incoming freshman class. So as you read through, it reviews all the things we've learned about how X bar is a sample mean in this case that we use to estimate mu, which is the population mean. So he's basically going to talk to or give the IQ test to 50 of the 5,000 freshmen. So all the things that we learned in the last chapter about conditions still apply, and we can use the sample size, which is 50 right here, and the standard deviation for the population, which they just happen to know, probably because they've done this with a lot of groups, and so 15 is the normal standard deviation that they've arrived at over a lot of years. So population, standard deviation, square root of the sample size, and that gives us a standard deviation for this sample. So you should take the time to look in the book or pause the podcast and read these facts. All right, these are all a review of things that we've already talked about this year to see how they make these decisions about how come this is a 95% confidence interval. You see the empirical rule here that we talked about earlier, and we're going to get more exact confidence levels by actually using the Z-score and norm-win programs that we did earlier in the year. And I just remind you that there are specific commands on the calculator to make all these different confidence intervals that we're going to learn in this chapter. So there's a lot of information here, and it seems a little overwhelming, but just try to refresh, try to read it a couple times, and try to recall what we've done earlier in the year. And then it comes to this. For all that review, all that information that we've done in the past, it boils down to this simple thing. We take a sample of 50 kids and we give them an IQ test, and the average score is 112. And because the sample size is 50, we get a standard deviation of 2.1. And so to get a 95% confidence interval, we simply double the standard deviation. Remember, two standard deviations above and below the mean gives us 95% of all values. So what they actually do here is just go 112 minus 2 times the standard deviation for the lower boundary, and 112 plus 2 times the standard deviation to get the upper boundary. And the reason this is a 95% confidence interval is because of the two standard deviations. Remember, we said 95% of all values in the population will be within these two standard deviations. So a 95% confidence interval just means I pick a low boundary and a high boundary between which I am 95% confident that the true population parameter, in this case, the true mean IQ score for everyone in this freshman class, lies. And we'll pick up with some examples in the next podcast.